Hello and welcome to another video. This time we're going to be looking at the PCF8574. This is an i2c expansion port. This one has an 8-bit I/O port, so we can add an extra 8 inputs or outputs to our Agon. On the side of the module we can see the 4 connections for our i2c bus. There are also 3 tabs we can change to select the actual bus ID we want to use. This means that there are actually 8 different possible combinations of number we could use. So we could have 8 of these modules plugged in at the same time, giving us 64 extra I/O ports. At the top of the board you can see the I/O pins, and they're numbered from 0 to 7 from right to left. There's also an interrupt pin, but we won't be covering that today. What we'll be looking at in this video is how to switch on an LED. Obviously you could be switching on all sorts of devices, but an LED shows that it's working. We connect an LED to the input pin and then through a resistor to a 3.3 volt supply. That's the same supply which was given to the actual module. The way this module works is that the I/O pins are normally high. When the pin is high, there's a balance between the pin and the 3.3 volts. When we turn the pin low, the current can then flow and the LED will illuminate. For the purpose of this demonstration, I've wired up 8 LEDs, each one going through a resistor and each one going to one of the pins on the module. If we look at our code, some of it will be very familiar from previous videos. The start is much the same as before, although we are defining an i2c address of our module. In this case it's 20 hexadecimal. We're going to clear the screen and print a message to our Agon screen so we can see that something's actually happening. Next we open the i2c bus, and that's a very simple MOS call. We load C with the speed setting we want to use, and MOS call 1F opens the bus. Next we'll configure the pins. We do this because the module wants to know when it first boots up which pins are inputs and which pins are outputs. So configuring the pins, we load C with the i2c address of our module. B is the number of bytes we're going to be sending, and it's only 1. HL is the buffer of data we're going to send, and we're going to load the first byte of that buffer with all ones. That is, all of the actual pins are going to be outputs, and we make MOS call 21. In this example, we're briefly going to put all pins on. All pins on does the same sort of thing, except this time it puts 0 into every pin. As we saw from our diagram, if we send any pin low, it will actually light up the LED. Next we head into a loop. It does a few things. Firstly, it checks if we've pressed the escape key, and we've covered this code previously. Next, it's going to move the LED along. And finally, we'll have a little bit of a pause between each move. What we've got here is an initial bit number, and this is going to be the pins, and they're all set high except one of them. So what we do is we read that bit number into A, we rotate it by 1 position, and then we store it again for next time. And as previously, we send a byte out on the i2c bus, and it's this byte that we're going to send. So each time we go through this loop, it will change which of the pins are high and which one is low. So if we run our code and look at our module and our LEDs, we can see we had a momentary flash of all LEDs coming on, and then in turn the LED which is on moves from left to right and cycles around. Hopefully now you can see how easy it is to add more input and output pins to your Agon. In another video we'll look at how we use the inputs on this module. Hopefully you can find ways of using this in your own projects.